Hi, this is John Russell, editor of HPCwire, and with me today is Gilad Shainer, VP of Marketing for Mellanox. Gilad, I haven't seen you for a while. I think actually it might have been ISC or the New York event, and a lot of things have happened with Mellanox since then. But before I ask you about the new product sets, I thought maybe you could just give us a sense of the conference, how's it going, what are your impressions so far? I know it's the first day.
Yeah, and thanks, John. Supercomputing is always a great place to come in and see the technologies that are being developed and where the industry is pushing and how the users are using that technology. I think we're seeing the race to exascale, and it's kind of a common element in supercomputing. People are talking about developing the hardware and the software and the rest of the elements in order to get us to the exascale. I think many people already have in mind what can they do with exascale machines. So the need is there, and there is a huge collaboration, I think. And I see that as one of the highlights of this year. You see more and more collaborations, more and more people talking about co-design as the ability to create synergies between the software and the hardware, and create synergies between the hardware elements in order to overcome the performance walls of today and enable us to go to the next level of performance, right? If you think about it, in like 20 years, we're going to see 1,000,000x performance improvement, which is amazing. And every time there was a technology change that enabled us to move to the next level, right? For example, moving from SMP to clusters enable us to go to the terascale era. And clusters essentially relies on the interconnect, because the ability to take off-the-shelf servers and connect them together to form a supercomputer requires a very, very fast interconnect for that. There was also the technology change that happened in the petascale era, moving from a single core to multi-core, because you couldn't get any more performance from frequency of CPUs. And now when you have more and more processes running on every node, it means that the network needs be much more efficient and be able to support multiple processes. So there is more and more intelligence that is moved into the network in order to enable that. And now we're going toward the exascale. We're going through another technology change, which is the co-design to create synergies, because the idea of let's run everything on a CPU got us to performance walls of today. So if you want to overcome those, you need to look into the entire application, the entire framework of what you want to execute, and use every active component in the data center to be part of the application. So you have the computing elements. Now the networks start to provide in-network computing. So you can do things on the data when the data flies within the network. That can take you to a great performance advantages as we move forward. So we'll see more and more co-design. We're seeing a lot of discussions on co-design. And Mellanox, we're very proud to be part of multiple co-design work or development that is being done together with government labs, leading users around the world, and with our partners, OEMs.
I know you have, excuse me, I know you have the Coral project that you're involved in as well. Maybe you could talk a little bit about the products that you're going to be introducing, or at least sort of expanding here at the show. I haven't been to the booth myself yet. I will, but I know you've got several new things out. The new InfiniBand switch, and I guess there's another, your intelligent connect and a connect switch. So, what are you showing at the conference this time?
Okay. For us, we had a very important announcement from Mellanox. We announced the new EDR switch, which is called Switch IB2. And the major element in Switch IB2 is that it's the world's first smart switch. And the reason that we call him the world's first smart switch is because this is the first time that you can execute and manage MPI collective operations on the switch silicon, instead of doing that on the server side. And that enables us to provide a 10x performance improvement versus what exists today. And to understand it, it's very simple. Today when you run a collective operations on the server for MPI, HMPGAS, or UPC, the server needs to have multiple transactions over the network to connect that node to any other node in the system in order to complete one collective operation. Now, anything you do in a server will not be able to overcome that issue. So now moving the execution and the management of collective operations to the switch, and the switch is an entity that connects to all of the nodes, enables the switch with one parallel transaction over the network to complete MPA operations in one communication operation. And that's a 10x performance improvement. This switch is part, by the way, of the Coral project. So the Coral was announced a year ago, but some of the elements within Coral were not announced back then because they were confidential. But the capabilities of Switch AB2, the intelligence is part of the switch. Now the switch is essentially a coprocessor within the network. This is part of the Coral project, and it will accelerate other systems that are going to be deployed in 2016 and forward. So this was one of our major announcements, and we're very proud with the achievement and what can it do to application performance. We also announced some other products. We announced an adapter card that combine both NIC and an FPGA on one card. So that's also enable our customers with programmability elements that connect to the NIC, so they can use it for security, for analytics, for other intelligent elements as part of the network operations.
The whole idea of accelerating processing wherever the data is as opposed to forcing it on the server makes a huge difference, and you can take that latency out. One of the things that we're seeing at the conference this year, it seems stronger, is this convergence between the enterprise market and the traditional high-end HPC. And are you seeing that? It's sort of, I guess last night Intel's keynote, all about that. I met with IBM today. The same sort of story, that these two markets are really merging in many ways. What's the Mellanox view of that?
Yeah, if you look on the market outside of HPC, hyperscale, Web 2 or cloud, machine learning, or artificial intelligence, and other markets like that, essentially using the same technology that is being used in HPC. If those are GPUs or intelligent networks or RDMA. Right. RDMA, for example, started in HPC, but today it's the key element in any storage infrastructure. No one will run a storage infrastructure without RDMA. It doesn't make sense efficiently wise and cost wise. So there is a lot of technology that is common between the enterprise side and the high performance computing side. And that's why we're seeing a lot of things that are kind of covering both areas. And we're seeing people, or enterprise people, that participate in supercomputing because of that. So yes, we do see that. I think, in a simple words, what's common is that in the enterprise, they need to deal with growing amount of data. And I think that was expressed in multiple sessions in supercomputing. And the more you can do with the data, you can benefit from product development, getting insight, understand where to take the company, understand what's happening outside. The same things are being done in the HPC space. So that's why we see the converge, because both sides essentially need to solve the same kind of problems.
One question I've been asking around that is, the enterprise world, of course it's not just one world, right? There's lots of different sized companies, but they're maybe a little less able to adopt and use some of the HPC technology. So you need to make it, very accessible, whether it's cloud-based or whatever that is. What do you do to sort of take this, this population of would-be users who could use it, but maybe are not quite so skilled?
Yeah, I think first there are many cloud vendors or Web 2 vendors that are really smart, and they actually drive the technology there. Take, for example, OCP. All right, so Facebook initiated the idea of OCP, and you see more and more companies, even second tier of users that are part of OCP. This is one example of how you take technology that is being used for hyperscale or leading HPC and make that accessible to other companies. There are other organizations that are doing the same thing. For Mellanox, our solution fit both, and we provide management entities and capabilities to be able to have even simple users or small medium businesses to be able to leverage from HPC capabilities in order to progress their development and actually gain a competitive advantage. Outside of Mellanox, we also contribute a lot to an organization that's called HPC Advisory Council, which is a group of people that comes from all around the HPC area that drives or help on HPC outreach and education. So getting to more and more areas and enable people with the basic understanding on how to take HPC, because it's not that complex when you think about it, and be able to bring that to their company and leveraging from that to gain a competitive advantage.
Technology roadmap, looking at my list here, maybe you could talk a little bit about down the line. Interconnect is so important now. It really is a rate limiter in how fast we can make these machines run. And of course, Mellanox has some activities in the photonic area as well. Can you give us a sense of the technology roadmap at Mellanox and what you think, maybe even beyond, what's sort of on the horizon?
Yeah. So definitely the interconnect becomes a very important part in the data center. And it's not just the speed of the network, but it's also the intelligence that moves into the network and enable the network to do things which going to progress the performance of the system, increase the efficiency in amazing levels. In this conference, we announced SwitchIB2, which is a second generation of our EDR 100 gigabit per second InfiniBand. A few months ago, we announced the Spectrum switch, which provide 10, 25, 40, 50, and 100 gigabit per second for Ethernet. So serving both sides of the world. Moving forward, we plan to continue in having the generation ahead leadership that we have today, and we plan to release 200 gigabit per second, and maybe even 400 gigabit per second, and 200 in 2017 timeframe, and it's continue to drive the performance, the capabilities for that. We have acquired the silicon photonic technology to the company in 2013. And today we are the first company that ships silicon photonics cables to the market. So silicon photonics is part of our offering for 100 gigabit per second, continue to be the offering in the future. Of course, we'll see different things and different elements coming in the future, but looking ahead, Mellanox aim to continue in being a generation ahead over the competition, driving the speeds, driving the intelligence, and enable the interconnects to give an in-network computing for accelerating applications.
Some of the technologies you've just been talking about, we keep stretching and making them more and more powerful, but with the silicon limit, you almost wonder what we're waiting for really is a disruptive technology of some kind. So instead of just sort of being limited by silicon, what's the next thing that's going to drive that? One last question. Appreciate your time. You were talking about co-design earlier, and certainly you've been involved with this UCX framework effort, which would help make that happen. And I know you've got, I think, a Birds of the Feather meeting later on, perhaps do an update on that. Can you tell us a little bit about what's the progress there, who's involved, what would you like to see over the next few months in terms of milestones?
Yeah. So UCX, or OpenUCX, is another example of a co-design. So co-design creates synergies between software and hardware, between software and software, between hardware and hardware, so all across here. With UCX, the mission was to create a unified communication framework that is very low weight. So it connects directly to hardware level interfaces, so it enables much better performance, support any kind of infrastructure, and any kind of communication libraries, if it's MPI, SHMEM-PGAS, UPC. Now, there is always the dilemmas of people getting together and saying, there are so many software elements out there, let's create something new, a unified one, and you end with one more. So that's definitely not the motivation here. UCX basically was built by taking multiple communication interfaces or software interfaces that were out there and combine them into a unified one. And that's the strength of it. So Mellanox brought MXM and FCA, which was our communication interface, into the OpenUCX project. Oak Ridge National Lab brought UCCS, something that they developed for OpenSHMEM. IBM is part of it, bringing their elements. NVIDIA is part of it, and other companies. So now you see a unified, a very high performance, low weight software that is being created. At Supercomputing, we announced the intent to form a UCX consortium to bring the specification for UCX. As part of the initial consortium work, you will find Oak Ridge National Lab, Lawrence Livermore National Lab, Los Alamos National Lab, Argonne National Lab, University of Tennessee, Mellanox, IBM, NVIDIA, and other companies that got together in order to bring that, bring UCX out, because it's very, very important. We also start to release first performance numbers. Right. And UCX shows a very good advantages, even in that initial phase of it. Just to give you a basic numbers, on a simple latency test, that, ping pong on MPI latency test, that runs today in around 900 nanoseconds, we're already seeing reduction because of UCX, and now we're in a 700 nanoseconds and even less for an MPI ping pong. So it's, from percentage-wise, it's big. It's also going to help the more complex communications, of course. And that's the goal. So it's an open source, so things that were closed before now becomes open. Community can be part of it. We do call everyone to join and be able to leverage from UCX for their current future systems and applications.
Thank you. Appreciate your time. Hope you have a great conference. I know that it's always interesting watching Mellanox, and particularly now that the interconnect is such a big part of going forward. Once again, with me today, Gilad Shainer, VP of Mellanox, and thank you, Gilad. I appreciate it.
Thank you. Thank you very much.
Yeah.